West Mountain Radio's computerized battery analyzer is a powerful general-purpose lab instrument allowing the evaluation and direct comparison of various battery models, capacities, and chemistries. In this video, we will walk through using the CBA for power supply testing and solar panel profiling. One of the test modes included in the CBA standard software package is called Power Profile. Using this test mode, the CBA applies an initial load current draw to the power source being tested, holds that initial current for a set amount of time, then measures and records the output voltage. The CBA then increments the load current by a programmable amount, and again measures the power source output voltage. This sequence continues to repeat until the maximum programmed current level is reached. This process of increasing the load current while measuring and graphing the output voltage can be used to characterize power supplies, batteries, or solar panels to determine their maximum power output. Let's look at how to set up a test using the Power Profile mode. The Power Profile test includes some important programmable test parameters. Initial current specifies how much load current the CBA will draw from the source being tested at the start of the test. Final current specifies the maximum current draw to be used before stopping the test. Current increment sets the load current increase, in amperes, for each step in the test sequence. Increment rate specifies how long the CBA will maintain the load current before sampling and recording the voltage, after which it will move on to the next incremental current increase. The output graph can be displayed as voltage versus current or power versus current. If enabled, Show Voltage Notes will place a note above each sample on the output graph, indicating the output voltage for that specific load current test point. The battery type is where you can select what is being tested. This includes different battery types, power supply, solar panel, and other. Let's try testing a power supply. The power supply that we will be testing is a 15-volt AC-DC switching adapter. The CBA uses a power pole connector for the input, so our setup includes an additional cable between the power supply and CBA. The Detect button will detect the voltage and fill in the voltage field. The software detected 15.3 volts, which is close to the expected value of 15 volts, so we'll use the detected voltage. This power supply has 1.7 amps listed for the output. For the test parameters, we'll set the initial current to 0, the final current to 2.5 amps, the current increment to 0.1 amps, and the increment rate to 10 seconds. The voltage versus current output graph will show what happens to the voltage as the current increases. Click on the Start button to start the test. On the right side is a box displaying the live voltage. There is also a box showing information about the test that is running. The amp value will increase by 0.1 every 10 seconds. As the amps increase, the voltage should stay fairly steady for a while and then will dramatically drop off at some point. Since this test will take a few minutes to complete, we'll speed things up. A pop-up box will appear when the test is complete. It shows that the maximum amps for the test was 2.2 and the maximum watts was almost 8. The test took around 4 minutes. Click on OK to close the pop-up. You can hover over a data point on the graph to see details. The last data point is 2.4 amps and 0.3 volts. The output graph can be changed by clicking on the Chart menu and then Chart Properties. Click on the Graph Type drop-down menu, select Power versus Current, and then click OK. Notice that the left side of the chart now displays watts instead of volts. The highest data point on this graph shows that it reached 32.2 watts. This test demonstrates how a power supply can be characterized. The CBA's Power Profile test is also a great way to characterize solar panels. An interesting solar panel characteristic is the MPPT, or maximum power point. Remember that power, in watts, is simply determined by multiplying voltage times current. Solar panels exhibit a dramatic drop in output voltage as the load current increases. This means that to extract the best performance from a solar battery charging system, the charging current must be limited in order to maintain an optimum solar panel output voltage. In other words, overloading a panel dramatically reduces its output capability and should be avoided. The CBA power profile test can gradually increase the current load, while measuring and recording the panel's output voltage. This will let you easily determine the panel's maximum power output point under various sunlight conditions. Here is the test result of an 85-watt solar panel in sunny conditions. The chart is showing volts versus amps. As the current increases, the voltage of the solar panel decreases. With each increase in load current, the voltage drops more. Since looking at the power profile chart of volts versus amps does not clearly show the solar panel's maximum power point, simply change the chart to display power versus current. Now that power is charted, the maximum power point can clearly be seen. It's the highest point on the chart. This shows that when sunny, the maximum power of the solar panel is around 65 watts. If you were using a solar charging system like West Mountain Radio's Epic Power Gate, the charging system would automatically find and maintain this optimum performance point. It's also useful to see how a solar panel reacts to changing light conditions. The CBA power profile test can be used to characterize the solar panel's output power in less than ideal lighting situations. After testing the solar panel on a cloudy day, it was found to provide around 12 watts. The CBA software allows you to graphically overlay test results for direct comparison, so you can easily see the differences between output profiles on a sunny day versus a cloudy day, or with the panel mounted at various angles to the sun. Thank you for watching, and be sure to check out the other West Mountain Radio computerized battery analyzer videos in this series on our YouTube channel or social media. If you wish to purchase the computerized battery analyzer, feel free to visit our website or just give us a call.